Okay, we've got someone coming home from work, possibility of 2 routes. For the first one, on route A, her journey time is called X, and it's normally distributed, so we know what topic we're on. We've got a mean, so that's a value of something, and a sigma, that's a value of something, and we've got to do some probabilities. We're finding probabilities, so this is forwards. So, your sequence for a normal distribution. Say what X twiddles. N something, it's a normal distribution. Say what mu is, say what sigma is. Be very careful that you're dealing correctly with sigma and sigma squared. Okay, we want sigma here. Okay, we want the probability of being less than a value. So you do your normal diagram. Okay, you know that this is a z of 0 in the middle. You know that the mean is whatever the mean is, so put the mean on in the middle. Okay, so the value we're interested in, 45, put a line here or here, depending on which side of the mean it is. Shade one side of the line, we're less than that value, so shade the correct side of the line. So because it's forwards, you go straight to the diagram, but you use the z formula. Z equals something minus something over something. Put the values in, get a z value, and then use normal. CD on your calculator, you'll need an upper limit. Before that, you'll need a lower limit. Okay, so the Z you've got will be either your upper or your lower, and for the other, you're going to be using either minus 9999 or 9999, depending on which one it is. Okay, and then for the second one, same again. Now it's between 2 values. In fact, 45, you've already got the Z value for that, but we need a new Z value for the 30. We need a new picture. Okay, and now you're going to be using normal CD now with 2 Z values, so you've got a lower and an upper limit to put in. Okay. Alright, on to part B, her journey time by route B. That's another normal distribution with a mean of 40, but this time we don't know the standard deviation. We're just told to use sigma. And this time we're given a probability. Okay, so this is going to be a backwards question. So you don't be lazy. Draw the 4 pictures. Look here, I'm drawing 4 pictures. It's not very difficult to do. And once you've drawn them, all you have to do is pick the correct picture that fits what we're doing here. So we've got a not very big probability, and we want to be greater than a value. And then when you've chosen which one it is, then make it into a complete diagram, naught in the middle, put the mean on. And put on this 45. You should be able to work out which side of the mean it's going to be. And then from your probability that you're given, okay, make sure you're working with the left-hand probability because your calculator likes the left. Okay, and then you're going to use normal inverse on your calculator, and that's going to give you a Z value. Okay, and once you've got the Z value, then you can use the Z formula again. There's going to be a sigma in it because we don't know what sigma is yet. Substitute everything else into the Z formula, and you can rearrange, you can find out what the value of sigma is, and that's how you earn these 4 marks here. Okay, alright, now we've got some more stuff to do. We've got to thinking about her time of leaving. She wants to arrive by 9 o'clock, so therefore, we're interested in whether her journey time takes less than a particular time interval. So how long is this? Okay, maybe you've done some calculations involving that time already. So you want to basically make sure she's as likely as possible for her journey time to take less than this gap here. Okay, and you've got to give your reasoning, so you can't just guess route A or route B. You have to give your reason for the one you said. So quote a suitable probability or a comparison of probabilities. Then in part D, now she's travelling from home to work by car, and we've got a mean of 18 and the standard deviation of 12. Unlike the previous cases, they're carefully not telling us the distribution it is. We're going to be estimating the probability for a random sample of 36 journeys that her mean time is more than 20 minutes. So we're finding a probability, okay? Although this isn't normal, we're working out a probability of a mean. So we're going to be using an X-bar distribution. I mean, they're saying W. You can use W bar if you like, but essentially it's an X-bar distribution. Okay, so think about what X-bar might twiddle, and crucially, you need to think about what mu is, and for an X-bar question, we need to think about the standard error. Okay, but otherwise, it's drawing a suitable picture, a bit like that one, and coming up with a z value from the formula. So now z equals, use the x bar version of the formula. So you're not going to be dividing by sigma anymore. You're going to be dividing by the standard error. Okay, but otherwise it's just a forward question. So you're going to be using normal CD again. You're going to be using your sketch to work out whether your z value is a lower or upper limit. And you should be okay finding a probability. And then you've got to indicate, all right, where, if anywhere in this question, you needed to make use of the central limit theorem. Okay, and the central limit theorem is the one that tells you that even if the parent population isn't normal, then as long as the sample size is sufficiently large, then you can assume a normal distribution for a sample mean. So have you used that anywhere in the question? I've made that quite easy, haven't I?